Miscellaneous exercise 13. The first question is about finding derivatives using first principle. So I'll go to second sub question there, which is minus x whole raised to minus 1, which is just minus 1 by x. And now by first principle means definition. So what is f dash x? You know, it is limit h tends to 0 f of x plus h minus fx upon h. So this is equals to limit h tends to 0. What is f of x plus h? We did it number of times, so you know it. In this, instead of x, you write x plus h. So minus, instead of x, x plus h. This minus and this minus will be plus now. This is 1 upon x upon h. Now we just simplify. So you have limit h tends to 0. Do the cross multiplication here. So this is minus x plus h upon x plus h into x into h. You know, this is polynomial upon polynomial. H minus 0 should get cancelled. So it will get cancelled very easily. You can see this x will get cancelled. Then this h's and this h will get cancelled. So we are left with just this much. Limit h tends to 0. In the numerator you are left with 1. And x plus h into x. Now we apply the limit. Apply the limit means instead of h you put 0. So this is x and this is x. So you have 1 by x squared, which is derivative of the given function by first principle. We go to fourth sub question now. Fx equals to cosine of x minus pi by 8. Okay. So what is f dash x? Recall limit h tends to 0 f of x plus h minus fx upon h, which is equals to limit h tends to 0. What is f of x plus h? In this formula, instead of x, you write x plus h. So we have cosine x plus h minus pi by 8 minus, what is fx? That is cosine, you know it is cosine x minus pi by 8 upon h. What we do? We just put the value of f of x plus h. What's the meaning of this? In this formula, instead of x, you write x plus h minus pi by 8 as it is. And what is fx? Cos x minus pi by 8. Now, what's the numerator? As we did earlier, it is c minus c. What is c minus c? Minus 2ss. You know, c minus c is minus 2ss, factor formula. So if I use that here, this is equals to limit h tends to 0 minus 2 sine. What you will get? You will get the 2x plus h minus 2 pi by 8, which is pi by 4, whole by 2. You know procedure. This angle plus this angle whole by 2 into here sine. This angle minus this angle. So pi by 8 will get cancelled. X will get cancelled. You are just left with h by 2 upon h is already there. What we did? This plus this by 2. This plus this by 2. So 2x plus h, double of this, minus 2 pi by 8. This minus this, x will get cancelled, pi by 8 will get cancelled, and h by 2. Now, you know, Very well. In limits question involving trig function, you need to set sin x upon x where limit x tends to 0, which is 1. Now here you have h by 2, so I must have by 2 into 2. This is very commonly used technique, in limit question involving trig function. Why no need to set for this? Because if you apply h tends to 0 here, this will not be 0, you can verify. So if you use this concept here, we have, see this much, this 2 will get cancelled. Here this much will be 1, this is just 1. Sin x upon x as h tends to 0, this is 1, using this concept. And here you can apply h tends to 0. Minus sign is already there, this minus sign. We have sin h tends to 0. So 2x minus 2 pi by 8, this is 0, the whole by 2. So 2 will get cancelled. So we have here minus sin, this is x minus pi by 8, that is required derivative with minus sign. 2 you can take common and it will get cancelled with this. So minus sin x minus pi by 8 by first principle, that is the derivative. Remaining 2, that is first one and third one for you must try. So first and third by first principle, this for you, try it. We did number of questions. Now question number 2 onwards, second 2 till last question, that is till 30th, all are about standard derivatives and working rules. There clearly it is mentioned that a, b, c, d, p, q are all are constants. M, n are integers, means they are also constants, and you want to get the derivatives. How? By working rules, not by the first principle. Like this, I'll do some of them, not all. D by dx of which function? X plus a. Derivative of x with respect to x1, derivative of a being constant 0, so derivative is 1. Derivative of x plus a. Question number 3, third one, which function you are given? Px plus q into px plus q into, you have r by x plus s. Now there are two ways. Directly you can use the working rule, or you can open the bracket and then you can do the differentiation. I'll just open the bracket. So this into this, xx will get cancelled, it is just pr. Then what about this? S into p into x plus, what is this? qr by x, and this is qs. What I did, I have just opened the bracket, yet I have not done the differentiation, right? Now I'll do the derivative. So I'll write d by dx in front of this, which is same as you write d by dx in front of this. What you did? Just simplification. Now we differentiate this. What about pr? Both are constant, derivative is 0. Sp being constant with the function as it is, so differentiation of x with respect to x, which is 1. Qr being constant as it is, you are left with how much? 1 by x. What's the derivative of 1 by x? Minus 1 by x squared. Recall this, we did it. Derivative of 1 by x is minus 1 by x squared, right? And qx being constant alone, derivative is 0. So finally you have sp minus qr by x squared, which is a required derivative here. sp minus qr by x squared. What I did, I opened the bracket first. You can do directly just by using product rule. Even that can be done, remember. Choice is yours, whichever way you want to do. Fourth one, there the function is ax plus b into cx plus d the whole square. Now for whole square we don't have any formula. So what we need to do, before we differentiate it, we need to expand this. C squared x squared plus twice c dx plus d squared. Now there are two ways. You can open these two brackets and then you can differentiate it, or you can use directly walking rule. Fine. Using product. So I want to differentiate this. So d by dx of this function here, that is equals to d by dx of this. Why we have opened this bracket? Because for whole square we don't have any formula right now. We have such things, but that we'll study later on in 12th standard, not right now. Product rule, this one as it is, ax plus b as it is. Differentiation of this one, c square as it is, derivative of x square 2x. 2cd as it is, differentiation of x with respect to x1, and d square being constant 0. So this is 1, I'm sorry, plus still the other part is left. What is the other part? Now this bracket as it is, c squared x squared 2c dx plus d squared as it is, differentiation of this portion. B being constant alone, derivative is 0. Here a into differentiation of x with respect to x1, b being constant alone, derivative is 0. So this is derivative. Now if you want to just match the backside answer, you can open the bracket, or if I just simplify, you can find 2c common from this. So ax plus b as it is, 2c if I take common, you will get the cx plus d plus this is that perfect square, cx plus d the whole square. That's the required derivative. This step is not important. Important one is this step, product rule. As it is, differentiation of this portion here. Now this as it is, and differentiation of ax plus b. A being constant as it is, derivative of x with respect to x1. B being constant alone, derivative is 0. So we get this after the simplification. Then fifth one. Fifth one is very standard division rule. We have ax plus b upon cx plus d. Division rule, I hope you are very clear with that. We did it number of times in previous session. So derivative of this. What is division rule? Square the denominator function cx plus d the whole square. Then cx plus d as it is here. Differentiation of this one. What is differentiation of this bracket? There, b being constant alone, derivative 0. Derivative of ax, that is just a. Differentiation of x is 1. Derivative of b being constant alone, 0. Minus, here, minus. Now which bracket as it is? Here ax plus b as it is. And differentiation of that bracket. Which bracket? This one. C being constant as it is, derivative of x with respect to x is 1, d constant alone, derivative is 0. So we have cx plus d into a minus ax plus b into c upon cx plus d the whole square. Over here differentiation is over in this step. I hope that is clear to you. Now we are just simplifying. So if you simplify this, cx will get cancelled. So we'll get the AD minus BC upon cx plus d the whole square. That's derivative. Okay. What about sixth question? Question number 6. There in the sixth question, if you simplify, you have x plus 1 upon x minus 1, just taking LCM, right? I hope this is correct. And then you differentiate it, d by dx of this function. Now do it and check the backside answer. Okay, seventh question, we again use division rule. The function is this 1 upon ax square plus bx plus c, and you want the derivative d by dx of this expression. So we squared the denominator function, ax square plus bx plus c the whole square, squared the denominator function. Now what about numerator? Ax square plus bx plus c as it is. Differentiation of 1 being constant alone 0 minus, now 1 as it is. Differentiation of this one, what is that? A as it is, differentiation of x square 2x. B being constant as it is, differentiation of x1. C being constant alone, derivative is 0. So this term will be 0. You have just minus 2ax plus b upon ax square plus bx plus c the whole square. Division rule in the 7th question. Fine. I hope now at least you are clear with all working rules. Okay. Question number 8th and 9th both are about division rules. I'll do one of them. Let's do 9th. There the function is px square plus qx plus r upon ax plus b. How will differentiate this? By division rule. So d by dx of this function. We'll use division rule. So this is equals to, what is division rule? Squared the denominator function. So I'm squaring ax plus b the whole square. Then ax plus b as it is here. Differentiation of this. P being constant as it is. What's the derivative of x square? 2x. When you have constant with the function as it is, differentiation of x square 2x. Q being constant with x as it is, derivative of x with respect to x1. R being constant alone, derivative is 0. Minus, now minus, which one as it is? This px square plus qx plus r as it is. Differentiation of this. A being constant with the function as it is, differentiation of x with respect to x is 1. So a into 1, that is just a. B being constant alone, derivative is 0 here. So this is very important step. Now what you need to do? You just need to open the numerator bracket and need to simplify. Denominator expression as it is. Ax plus b the whole square as it is. Right? You just open this bracket and simplify and check your answer. Right? Just need to open the bracket. So that much you can do. Okay. Next question. Question number 10. In the 10th question, you have a by x raised to 4 minus b by x square plus cosine x. There are 3 terms. We want the derivative of this function. So here d by dx of this expression. This is, I can, before I differentiate it, I'll write the one more step. Yet I'm not differentiating. A into x raised to minus 4 minus b into x raised to minus 2 plus cos x. What I did, I took that x raised to minus 4 in the numerator. A being constant as it is. What is derivative of x raised to n? Using this concept, n into x raised to n minus 1. So you have minus 4 x raised to minus 4 minus 1 like this. Minus b being constant with the function as it is. What is this? This is minus 2 into x raised to minus 2 minus 1. And derivative of cos x, which is nothing but the minus sign. If you see first, then minus sign. So if I just rewrite this, here minus 4 as it is, this is total minus 5 power. So upon x raised to 5. Plus, here minus minus will be plus 2b. This is nothing but total 3 power, so x cube minus sin x. That's required derivative. Okay. Now next, 11th. It's very trivial question. 11th, you have 4 root x minus 2. We did this too, if you remember, x raised to 1 half. So root x, which is, if you remember, 1 by 2 root x, already explained. And one more important, 1 by x minus 1 by x squared. These two derivatives you can write directly. So here d by dx of this, what's 4 being as it is, derivative of root x, 1 upon 2 root x. 2 being constant alone, derivative is 0. So this is 2 by root x. That's required derivatives here. Then next, that is 12th question. Oh yes. So this is ax plus b whole raised to n. Now we don't have any procedure to differentiate this. So what you can do, you can use the product rule, and you can write like this: ax plus b into ax plus b into ax plus b. How many times? N times. This is one way of differentiating this. I'll tell you how to do it directly even. How many times I've written ax plus b, n times. This I wrote how many times? Let me write here n times, because you have raised to n. Fine. Now what we do? We differentiate this. So we use the product rule. Now what is the product rule? Product rule says that you differentiate this, keep all these as it is. Then you differentiate this, keep remaining all as it is. Then you differentiate this, keep remaining all as it is, and so on. So one procedure n times. Remember, I'm differentiating this. What's the derivative of this? It is just a. Differentiation of x is 1, derivative of b is 0. So it is just a. This all as it is. But this is how many times? N minus 1 times. Because one time you already used. So I'll write ax plus b raised to n minus 1. I hope this is clear to you. I'll explain one more time. See, differentiation of this one, which is a, which is clear to you. Remaining all terms as it is, as per product rule. Now this, how many terms are there? These are n minus 1 terms. Because total you have n terms. One term you already used here, so n minus 1. Now product rule, so plus. Now it is term of which one? Iska derivative आपको करना है. Differentiation of this one. What's the derivative of this one? X derivative x with respect to x1, a as it is. Differentiation of b is 0. So here just a, ax plus b, x plus b, x plus b. How many times? N minus 1 times. So raised to n minus 1. How many times this will occur? N times. Fine. So single term n times. It's like if you have x plus, if you do n times. So what is that? It is nx. If you write x 3 times, it is 3x. x 4 times, it is 4x. So here this term, how many times? N times. So n into ax plus b raised to n minus 1. This is required derivative. Right? Now you cannot do in subjective this method, or we can do like this also, or this is called chain rule actually, which we will do next year in 12th standard. What is chain rule? See, come to this. What we do in the chain rule, we imagine this is like x. You imagine that bracket as like x. Consider this bracket as x. So this looks like x raised to n. What is derivative of x raised to n? That is n into x raised to n minus 1. So I'm doing that. N into x, you are considering, you are not going to write x, you are going to copy the same expression. Ax plus b, 1 less power. I hope this is clear to you. This, what I did, I have considered that bracket as x. You consider this bracket as x. So n into ax plus b raised to n minus 1 less power into, now chain rule says that differentiation of that considered x. So what's the differentiation of this? Here you know very well, as I did number of times, derivative of x is 1, a as it is, derivative b constant alone 0. So it is just a. So finally you will get the n into a into ax plus b whole raised to n minus 1. Fine, this is chain rule. Normally this should not be used in subjective as far as 11th standard concern. In 12th we'll do this. I repeat, what I'll do, I'll imagine this as x. So this is x raised to n. What's the derivative of x raised to n? N into x raised to n minus 1. I'm not going to write x. We just imagine that as x. Fine. So this bracket as it is into, the chain rule says that the derivative of that considered x. So derivative of ax plus b, which is just a, and therefore this is required derivative. Question number 14. Sine of x plus a, you want derivative, so d by dx. Now here you don't have derivative of sine of x plus a. So what we do, before I differentiate it, I'll just open the bracket, remember. So I'll open the bracket by addition formula. If you remember, sine x cos a plus cos x sine a. Here a is constant, you know. Now this can be differentiated very easily. How? See, cos a constant, so as it is. What is the derivative of sine x? It is cos x. Plus, now sine a being constant as it is, because it is with the function. What's the derivative of cos? It is minus sine. I repeat, what I did? First, I have opened this bracket by addition formula from trigo. This, you don't have derivative of sine of x plus a. You just have derivative of sine x. That you know very well. So this cannot be differentiated directly. So I've used the addition rule. Now cos a is a constant because there is no x. So this one as it is. What's the derivative of sine? Cos. Plus as it is. Sine a being constant as it is. What's the derivative of cos? Minus sine. Now if you observe this, this is just addition formula. Which formula? Cos x into cos a minus sin x into sin a, which is nothing but the cos x plus a. You expand this, you will get the above step. Or you can do by chain rule. Right. This is not advisable in subjective. In MCQ you can do this, or by chain rule. This is from 12th standard actually. See, what is the chain rule? You don't have derivative of sine of x plus a. So you imagine this is like x. So it looks like sine x. You consider this bracket as x. So it looks like sine x. What's the derivative of sine x? You know it is cos x. So I'll write cos of that bracket. As I told you, you are not going to write x. You are going to copy that bracket. Into, the chain rule says that differentiation of that x. What's the derivative of x? 1. What's the derivative of a being constant alone? 0. So cos of x plus a. That is required derivative. Fine. Now 15 number. You have cosec x into cot x. Product of two functions. So straightforward product rule. Product of two functions. So we use product rule. What's a product rule? One function as it is into differentiation of the other function. Always plus sign. Cot x as it is, differentiation of cosec x. You have product in the function, so we use the product rule. This one as it is, derivative of cot, always plus. Cot x as it is, derivative of cosec x. Now cosec x as it is here, what's the derivative of cot? Minus cosec squared. You know, derivative of cot is nothing but what? Minus cosec squared. What about this? Plus this cot as it is. Do you remember derivative of cosec x? Minus cosec into cot. Whenever you have c, then always you have minus sign. Right? So you are through in differentiation. Now we just rewrite minus, this is cosec cube, and this is minus, you have cosec x into cot square. We have product of two functions, so straightforward we have used which rule? Product rule. Now 16, 17, 18 all are about division rules, so I'll not do that. 16, 17 and 18, these three questions use division rule. We did it number of times, so I'm sure you can do this. Use division rule for next three questions. Question number 19, I'll do it for you. So in the question number 19, you are given sine raised to n. You want the derivative of this, right? Now we don't have any rule for sine raised to n. Fine. So what we do, I'll imagine this sine x as x. So it looks like x raised to n. What's the derivative of x raised to n? You know, n into x raised to n minus 1. So n into x means sin x here. So sin x raised to n minus 1 into, by chain rule, you are using chain rule, remember. By chain rule, differentiation of that considered x. Which one you had considered as x? Sin x. So what's the derivative of sin x? Cos x. So n into sin raised to n minus 1x into cos x, which is here required derivative. I have used which rule? Chain rule. Imagine that sin as x, so it looks like x raised to n. What's the derivative of x raised to n? N into x raised to n minus 1 into here differentiation of that considered x. Which one you had considered x? Sin x. So what's the derivative of sin x? Cos x. This is by chain rule. Or if I do directly, right, it is similar to one of the question number 12. It's just same as this question number 12, raised to n. Product rule n times. So I'm showing that. Okay. So here you have sin raised to n with derivative. So what we do? We write d by dx of here sin x into sin x into sin x and so on into sin x. How many times? N times. Sin x, how many times? N times. Right? Now product rule. What's the product rule? As I explained number of times, you differentiate one, keep this one as it is. Differentiate, first you differentiate this, then differentiate this, keep remaining as it is. Then differentiate this, keep remaining as it is. Do that thing how many times? N times. Fine? So I'm differentiating first. What is that? Cos x. Remaining all as it is. That is sin x, sin x, sin x. How many times? Can you tell me? This is how many times? N minus 1 times. So I'll write directly sin raised to n minus 1. Plus, always plus, you know, in the product rule. Now, differentiation of the second one. What's the derivative of sin x? Cos x. Then sin x, remaining sin x as it is. How many times? 1 you already used. So n minus 1 times. And so on. Till the last one. Now, differentiation of this last one, which is cos x. You are left with how many sin x? N minus 1. So sin raised to n minus 1x. Fine? Clear? So this you did how many times? N times. First sin turn cos, then second turn until nth one. This you did how many times? N times. So n into cos x raised to sin raised to n minus 1. This is by product rule as per your textbook method. Here this I did by chain rule. I hope this is now clear to you. like this. If I take some example, suppose I want to differentiate sine cube. So you can do by chain rule. What I'll do, I'll imagine this as x. It looks like x cube. What's the derivative of x cube? 3x square. So here derivative will be 3, 1 less power, sine square into, by chain rule, differentiation of that x. What's the derivative of sine x, which is cos x? So 3 sine square cos x. What I did, I've used here chain rule. In MCQs, you can use this concept. One more I'll show you. Suppose I have 10 raised to 6. So what I'll do, you don't have derivative of 10 raised to 6. So I'll imagine this as x. So it looks like x raised to 6. What is derivative of x raised to 6? That is 6 into 10 raised to 1 less power. Derivative of x raised to 6, 6 into x raised to 5. Into differentiation of considered x. What is the derivative of 10, which is nothing but 6 square. So 6 into 10 raised to 5 into 6 square. 20th is also about division rule. I'll go to 21, which is sine of x plus a upon cos x. Now directly you cannot use division rule because you don't have derivative of sine of x plus a. So what we do, as we did earlier, we expand it. So before I differentiate it, this is sine x into cos a plus cos x into sine a upon cos x. So this is equals to d by dx sine by cos, which is 10x into cos a plus cos x will get cancelled, which is sine a. What we did, expanding this, sine x cos a plus cos x sine a upon cos x. Then just do individual division, these upon this, these upon this. Now we differentiate this. Yet we have not done derivative, we just simplified. Cos a being constant with the function as it is. What is derivative of 10? You know, 6 square. Here sine a, x is not there, it's a constant alone, so derivative is 0. So finally you are getting cos a into 6 square x. If you want, you can write cos a by cos square x. Like this you can write. Okay. 22, you can have just product rule. X raised to 4 into 5 sin x minus 3 cos x. We use product rule here. D by dx of this one. So for example, x raised to 4 as it is, differentiation of this product. So 5 as it is, what's the derivative of sine, which is cos x, minus 3 as it is, derivative of cos is minus sine, so plus sine x, plus product rule. You have product of two functions, one is this, the other one is this. Keeping this one as it is, differentiating this. Now 5 sine x minus 3 cos x as it is, into differentiation of this. What is that? 4x cube. Fine, clear? What I did, I have just used the product rule. Now here differentiation is over. You can take x cube common. So we are left with x here, 5x cos x plus 3x sin x. Here we are left with 4. So plus 4 5s are 20x minus 12 cos x. That's differentiation by product rule. Okay. Next, 23rd is again about product rule. 23rd is about product rule. 24th is also about product rule. 25th, 4th, 5th, these are about product rule. Okay, 26th, same division rule. I'll go to 27th. X squared cos pi by 4. Right? It is a constant, you know the value of cos pi by 4, which is just root 2. So root 2 x squared, 1 by root 2 x squared upon sine x. So now we differentiate it. Okay, so d by dx of, this is constant, so I'll keep it outside. X squared upon sine x. How we'll do this? Differentiation by division rule. 1 by root 2 I have taken outside from the beginning because it is a constant. You know one of the working rule. So here in this question we use now division rule. What is the division rule? Square the denominator function. Now here sine x as it is. Differentiation of x squared 2x minus now x squared as it is, derivative of sine, which is cos x. Fine, you can take, if you want, x common, so x into 2 sine x minus x cos x upon sine squared, and this is just 1 by root 2, so I'll write here by root 2. That is required derivative. I've taken that 1 by root 2 constant from the beginning because when you differentiate constant with the function, then constant remains as it is, just you need to differentiate the function. 28th by division rule. What about 29th? It's again, you can use product rule. X sec x into x tan x. We differentiate this by what? Product rule. So d by dx of this. So x sec x as it is. Differentiation of this. Derivative of x is 1. Derivative of tan is x square. Plus, now which one as it is? X minus tan x as it is. Into differentiation of this. What's the derivative of x? 1. What's the derivative of sec x? Sec x into tan x. I repeat, keeping this one as it is, differentiation of this one. 1 derivative of tan sec squared. Now this bracket as it is, differentiation of x is 1, derivative of sec is sec x into tan x. You just open the bracket and simplify. That's your answer. Right? You need to simplify. You cannot live like this. Okay. And now last question. There again you are going to use division rule. The 30th question. You have x upon sine raised to n, d by dx of this function. So what we do? We use division rule. Square the denominator function, sine raised to n, the whole square. Sine raised to n as it is, differentiation of, let me write d by dx of x minus, now x as it is, d by dx of sine raised to n. This is what the division rule. Fine. What I did, I have straightforward used the division rule. Squared the denominator function. This is that is it is derivative of x minus x as it is and sine raised to n. Now we write differentiation. Sine raised to n as it is, derivative of x with respect to x1, x as it is. Now this I'll write directly. What is derivative? We did it earlier. That is n into sine raised to n minus 1x into cos x by chain rule. I wrote it directly, remember. It is one of the earlier question. It was which question? If you remember, it was question number 19. This is just question number 19. Look at it, 19, you will realize. I wrote it directly. Upon, this is nothing but sine raised to n x the whole square. Fine. Now, is there anything common in the numerator? What's common? Yes, you can find sine raised to n minus. Remember here, differentiation is over. We are just simplifying. Sine raised to n minus 1 you will find common. So here you are left with sine x. Fine. I've taken n minus 1 power, so you are left with 1 power minus this n as it is, x as it is, cos x as it is, upon over here power of the power gets multiplied. This is how much? Sine raised to 2n power. You know this. If you have x raised to 2 the whole cube, it becomes x raised to 6. So here this is n power whole square. It becomes 2n, remember. Property of exponent. Now again n minus 1 and 2n. So in the denominator you are left with how much power? N minus 1 and n will get cancelled. So you are left with n plus 1 power. And this sine x minus nx into cos x in the numerator as it is. From 2n power, n minus 1 will get cancelled. So you are left with n plus 1 power here. And that's required derivative.